The war that Hitler imagined in 1939 was a war of blitzkrieg, fast armored divisions, shock infantry, and sudden, overwhelming force. What he did not anticipate was that the war's decisive turning point would occur far above the ground, in the cold, thin air where engines strained, metal groaned, and young aviators stared into a horizon filled with fire. By 1942, the United States had begun forging something entirely new, a strategic air arm powerful enough to reach into the industrial heart of Germany, dismantling its war machine from thousands of feet above. It was not immediate, nor was it inevitable. It was built through staggering effort, stunning losses, and an unbreakable belief that air power, if applied relentlessly and intelligently, could cripple a regime built on speed, surprise, and domination. The U.S. Army Air Forces entered the European theater with a bold, almost controversial doctrine: daylight precision bombing. Against the skepticism of Britain's Royal Air Force, which had shifted to nighttime area bombing after suffering devastating losses, American commanders insisted that hitting factories, shipyards, rail yards, synthetic fuel plants, and ball-bearing works in daylight could undermine Germany's war economy at its core. It was a staggering ambition to dismantle an industrial giant through the exact application of aerial firepower. The idea demanded bravery from the crews, engineering brilliance from manufacturers, and total strategic commitment from Allied leadership. Success was uncertain. Failure could be catastrophic. The B-17 Flying Fortress and the B-24 Liberator became the steel backbone of this vision. Rugged, heavily armed, and capable of flying long distances at high altitudes, they represented the technological leap required for such an audacious strategy. Yet even these legendary aircraft were not invulnerable. The early raids proved that the skies over Europe were among the deadliest battlefields of the war. German flak batteries filled the air with bursting steel, while swarms of Luftwaffe fighters attacked from all angles, using tactics refined through years of aerial combat. American crews, many barely in their 20s, took to the skies knowing that the odds of surviving 25 missions were perilously slim. Still, they returned to the air, day after day, because strategic air power required relentless pressure. By late 1942, American raids began probing deeper into German-held territory. Targets like U-boat pens along the French coast, aircraft factories, and rail hubs became early tests of the doctrine. Losses mounted, yet these missions revealed something crucial. The Luftwaffe could be forced into a defensive posture. For the first time since 1939, German war planners were forced to divert aircraft, train pilots, and critical resources away from offensive operations simply to defend the Reich's industrial arteries. Air power was beginning to shape the battlefield before the decisive turning points on the ground had even arrived. The industrial scale of American production played an equally critical role. The United States was building aircraft faster than Germany could destroy them, and training crews at a pace unmatched by any Axis nation. From factories in California, Texas, Michigan, and Maryland, waves of B-17s and B-24s rolled out with astonishing speed, each representing the combined labor of thousands of workers, men and women who understood that air power represented a strategic weapon as vital as tanks or ships. This industrial surge meant the U.S. Army Air Forces could absorb heavy losses and still grow stronger, something the Luftwaffe could not hope to match. Air power was becoming not just a military strategy, but a demonstration of America's industrial supremacy. Intelligence gathering became a critical component of America's air war. Through aerial reconnaissance, intercepted communications, and covert resistance networks inside occupied Europe, the Allies pieced together a detailed map of Germany's industrial lifelines. Fuel plants, ball-bearing factories, aircraft assembly lines, and transportation hubs were identified with scientific precision. For the first time in military history, a nation had the ability to destroy not just weapons, but the entire supply system that fed the enemy's war machine. This fusion of intelligence and strategic planning marked a new era of warfare, one in which battles were won not only through brute force, but through the targeted disruption of an enemy's economic heart. The psychological impact of American bombers was profound. For German civilians, the wail of air raid sirens became an unwelcome soundtrack to daily life. For German industrialists and military leaders, the growing intensity of raids signaled that their once invincible war machine was increasingly vulnerable. Hitler, who had built his empire on the illusion of unstoppable momentum, now faced a new kind of threat, one that arrived from altitudes beyond the range of his armies, striking at the infrastructure he depended on to sustain his vast military campaigns. Air power created a form of pressure that ground forces alone could never achieve. By the end of 1942, it was clear that the U.S. was not simply bombing targets. It was reshaping the axis of the war. Every destroyed factory reduced the flow of weapons to the Eastern Front. Every burning rail yard slowed reinforcements to Italy. Every crippled fuel plant tightened the noose around the panzer divisions that once swept effortlessly across Europe. Air power was not yet decisive, but the foundations had been laid. The stage was now set for a massive escalation, one that would turn the skies over Germany into the most fiercely contested battleground of the entire war. By the late 1930s, as Europe edged closer to war, a small circle of American military thinkers began to foresee a conflict unlike any the world had yet witnessed, one in which industrial production, not battlefield maneuvers, would determine victory. These men were the architects of what became known as strategic air power, a radical idea arguing that the center of gravity in modern warfare was not the soldier in the field but the factory that armed him. Their theories were controversial, often dismissed as academic fantasy by traditionalists who believed war would always be won by infantry and artillery. But as news of Germany's lightning conquests swept across Europe, these ideas, once confined to lecture halls, suddenly carried the urgency of prophecy. At the heart of this intellectual movement stood the Air Corps Tactical School, a modest institution in Alabama where a generation of officers quietly rewrote the doctrine of modern war. They studied reports from World War I, analyzed the explosive growth of industrial economies, and argued that precision bombing, directed not at cities but at key nodes like steel mills, electrical stations, and oil refineries, could paralyze an enemy without needing to destroy entire landscapes. Their vision was methodical rather than vengeful. Disable the machine, and the war engine collapses. This was not yet the reality of air combat, but it became the blueprint for America's approach once the war erupted. These theorists believed that air power had to be decisive, not auxiliary. Their lectures, diagrams, and simulations revealed how a modern economy depended on a surprisingly small number of irreplaceable facilities, industrial bottlenecks that, if destroyed, could ripple across the entire enemy war machine. German aircraft production, for example, depended on a limited web of ball-bearing plants and synthetic fuel refineries. If bombers could reach these targets and destroy them with precision, they reasoned, the Luftwaffe itself might wither. It was an elegant concept, but it required something America did not yet possess: long-range bombers capable of flying deep into hostile territory and returning home safely. That bomber would arrive in the form of Boeing's B-17 Flying Fortress, an aircraft that looked like a metal prophecy made real. Towering, heavily armed, and with an operational ceiling higher than most anti-aircraft guns could reach, the B-17 embodied the Strategic Air Command's boldest assumptions. Its creators believed a formation of these bombers could defend itself against enemy fighters through interlocking fields of machine gun fire. In theory, they would not need escorts. In theory, their altitude and toughness would keep them safe. It was a beautiful, dangerous theory, and the coming war would expose both its strengths and its heartbreaking limitations. The development of the B-17 was not simply a technical achievement, it was a political battle. Skeptics in Congress and the War Department argued that it was too expensive, too complex, too ambitious. They favored cheaper, short-range aircraft suited for tactical support. But as Hitler's armies rolled across Europe and the Luftwaffe demonstrated terrifying speed and coordination, the United States quietly realized it needed more than a conventional air arm. It needed a weapon capable of striking the war machine at its source. Funding finally surged. Factories retooled. And the idea of a long-range strategic bomber force transitioned from academic debate into national policy. Yet air power doctrine was still untested. The strategic bombing theorists were confident in their vision, but few had experienced the full reality of modern aerial combat. Cloud banks that swallowed formations, winds that drifted bombs miles off course, enemy fighters that could tear through even the strongest aircraft. Early training missions repeatedly revealed uncomfortable truths. Precision bombing was far more difficult in practice than in theory, and even the most sophisticated bomb sites required perfect weather conditions. Still, the Air Corps pushed forward. They believed that mastery would come through experience, and experience, tragically, would come through war. Then came Pearl Harbor. With a single morning of explosions, America shifted from reluctant observer to full participant in the fight against fascism. Almost overnight, Congress unleashed a flood of funding unprecedented in military history. Airfields expanded. Training centers multiplied. Production lines roared to life. The nation committed itself not only to building bombers, but to building the industrial ecosystem required to sustain them. Spare parts, replacement crews, fuel depots, navigation schools, intelligence networks. Strategic air power was no longer a theory. It was now a central pillar of America's war plan. As 1942 dawned, the United States possessed the world's most ambitious aerial blueprint, but also a sobering lack of experience in executing it. The theories of the Air Corps Tactical School would soon be tested not in classrooms, but in the skies over occupied Europe, where the Luftwaffe was seasoned, deadly, and determined. American crews, many barely out of training, would learn quickly that air power could indeed strike the heart of the Nazi war machine. But they also discovered that every mile toward a German target demanded courage, sacrifice, and innovations no theorist had fully anticipated. The test of American air power was about to begin, and the future of the war would hinge on whether those theories could survive contact with brutal reality. The first American airmen to reach Europe in 1942 arrived not as conquerors, but as students of a brutal new reality. They studied the fields of England where the RAF had fought the Battle of Britain, walked through hangars still scarred by Luftwaffe bomb damage, and listened to British crews recount missions that lasted hours but felt like lifetimes. These early American units, small, untested, and often unsure, were preparing to confront the most experienced air defense system on Earth. The Luftwaffe had refined interception to a deadly science, controlling the skies of the continent with radar-directed fighters, layered flak belts, and a network of airfields that responded with terrifying speed. Every American crew member understood that the strategic air campaign they had trained for in theory was about to become a test of flesh, steel, and nerve. What struck American officers most was how deeply integrated the German air defense system had become. Radar stations along the coast could detect Allied bombers minutes after takeoff. Ground controllers vectored fighters with precision. Anti-aircraft artillery, flak, could fill entire altitudes with black, exploding clouds timed to detonate at the exact height of incoming formations. This was not the chaotic, improvisational air war of the First World War. This was industrialized, systematic defense. For the strategic bombing doctrine to succeed, the United States would need to break through layers of steel and fire that no air force had ever overcome. Some British commanders privately doubted the Americans could manage it. Others believed the American focus on daylight, precision bombing was too dangerous, bordering on suicidal. But the U.S. bomber crews were determined to prove their doctrine right, or die trying. The first missions flown by the 8th Air Force were symbolic more than strategic. Small formations struck French marshalling yards, submarine pens, and industrial plants along the coast. These early raids revealed the promise and the peril of American air power. The B-17's toughness astonished the British, many returning with wings torn, windows cracked, and engines dead, yet still managing to limp home. But they also revealed the flaw at the heart of pre-war doctrine. Unescorted bombers were not invulnerable. German fighters attacked in packs, using coordinated head-on assaults that shredded formations. The Americans were stunned by the ferocity and accuracy of these tactics, and as the losses mounted, it became clear that the real test would come when the bombers pushed deeper into occupied Europe. Despite these early challenges, U.S. commanders refused to retreat from their daylight strategy. They believed the war could not be won unless America demonstrated it could hit Germany's industrial core with precision, not scatter bombs over cities at night. As the raids intensified, so did the determination of the crews who flew them. Many had arrived in England as teenagers. Within weeks, they had become men hardened by fire. They learned to trust the aircraft, to rely on each other, and to maintain formation even as flak tore holes in fuselages and shrapnel sliced through wings. Air crews quickly understood that survival depended not only on courage but on discipline. Tight formations amplified defensive firepower, and a single bomber drifting out of position could doom an entire group. The sky was a classroom, and its lessons were often written in blood. As 1942 turned into 1943, American air power began to build momentum. Production lines in the United States flooded England with new bombers, replacement crews, and advanced equipment. Airfields sprang up across East Anglia, forming what British civilians jokingly called Little America. Each base became its own world. Mess halls filled with loud laughter masking quiet fear, hangars humming with the clang of wrenches, and runways that never truly slept. This network of American airfields would soon support one of the largest air campaigns in human history. But even with growing strength, the Luftwaffe remained a formidable enemy, and each mission revealed new tactics, new dangers, and new questions about whether strategic air power could break the Nazi war machine before Allied armies stepped onto continental soil. The turning point of early American bombing operations came with the raids against the German submarine pins along the French Atlantic coast. These massive concrete fortresses, some with walls more than 10 feet thick, were nearly impervious to conventional bombs. The U.S. Air Force quickly learned that brute force alone would not shatter Germany's ability to wage war beneath the waves. New weapons, such as armor-piercing bombs and delayed fuses, were rushed into development. Precision became not just an ideal, but a necessity. The lessons learned against these U-boat bases taught American planners the value of intelligence, target analysis, and technological innovation, skills that would later shape the bombing campaign against Germany's industrial heartland. Behind the scenes, intelligence officers worked tirelessly to map the arteries of the German war machine. Through aerial photography, underground resistance networks, and decrypted communications, analysts pieced together a detailed picture of how German industry functioned. They discovered that vital targets, ball-bearing factories, synthetic oil plants, aircraft assembly lines, were vulnerable, but only if bombers reached them in sufficient strength. This dual requirement, mass and precision, became the guiding principle of the strategic air campaign. The United States would not merely attack Germany. It would dismantle it piece by piece, reducing its ability to produce planes, tanks, fuel, and munitions. But knowing what to hit was only half the battle. Reaching those targets would demand enormous sacrifice. As preparations intensified, American commanders understood that the coming year would determine the fate of the entire air campaign. If bombers could not penetrate to the heart of Germany and destroy its industrial lifelines, the Nazi war machine would continue to regenerate faster than Allied armies could destroy it on the ground. The crews knew what lay ahead: long missions over hostile territory, brutal encounters with seasoned German fighter groups, and the constant rattle of flak bursting around them like black flowers of death. Yet this grim reality also galvanized them. They carried with them a sense of purpose, a belief that every mission, every engine startup, every flight into the cold upper atmosphere brought the Allies one step closer to victory. And in the months ahead, their resolve would be tested in operations that pushed American air power to its limits. By the spring of 1943, American air power faced the defining challenge that strategists had predicted but few had fully comprehended: the need to push beyond coastal targets and strike deep into Germany, where the true lifeblood of Hitler's war machine pulsed within vast industrial complexes. The Luftwaffe had anticipated this escalation, reinforcing the skies over the Ruhr Valley with layers of radar, flak towers, searchlights, and elite fighter wings. To reach these targets, American crews would be forced to cross hundreds of miles of enemy territory, endure continuous waves of attack, and maintain formation a full hour or more inside clouds of flak that turned the sky into a black, boiling sea. These missions marked a new phase of the air war. No longer symbolic probing strikes, but deliberate blows aimed at crippling Nazi industry at its core. The Ruhr, often called Germany's industrial black country, was a fortress of steel, smoke, and fire. It produced the coal, iron, machinery, and armaments that sustained Hitler's armies, and German planners understood that its destruction would be catastrophic. As a result, The region was one of the most heavily defended airspaces on Earth. Anti-aircraft guns the size of naval cannons lined the valleys, guided by sophisticated fire control systems that adjusted for altitude, wind, and bomber speed. When American formations entered the region, flak gunners unleashed dense barrages that formed towering walls of black bursts, each explosion capable of shredding a bomber's aluminum skin or sending shrapnel ricocheting through bomb bays and fuel tanks. To survive, these missions required not just courage, but perfect discipline and unbroken formation integrity. The first major American raids into the Ruhr revealed the staggering difficulty of executing daylight precision bombing on such heavily defended targets. Even with advanced Norden bomb sights, bombardiers struggled to see through the thick haze of industrial smoke, artificial fog generated by German defenses, and the perpetual cloud cover that hung over the region. Some bombs fell short, others scattered wide, planes drifted in turbulent winds, and the Luftwaffe attacked with relentless ferocity. German fighter groups, flying Bf-109s and Fw-190s, coordinated their assaults with radar-guided timing, diving through formations with cannons blazing, then climbing back into the sun to strike again. The Americans soon realized that these missions pushed the limits of what unescorted bombers could endure. Yet despite brutal losses, the raids began to show that American air power possessed a resilience that surprised even seasoned RAF veterans. B-17s returned to England with wings shredded like fabric, control cables severed, and engines barely turning, but still managing to skid onto runways or crash land in fields. Crews staggered out, frostbitten, bleeding, exhausted, but alive. Each returning aircraft carried the marks of survival stories that defied logic. These battered bombers became symbols of the air campaign's grim determination, inspiring hope among the Allies that the Nazi industrial base could indeed be reached and struck. The photographs from these missions, though blurry and blackened by smoke, revealed something strategically important. Even partial hits on Ruhr targets disrupted production more severely than anyone had expected. American planners recognized that success in the Ruhr demanded not only courage but overwhelming mass. More planes, larger formations, tighter coordination, and continuous strikes that prevented German industry from recovering between raids. Production lines in the United States were accelerating rapidly, delivering bombers at a pace no other nation could match. New airfields were completed every month across England, and the 8th Air Force expanded from small, tentative groups into vast wings capable of launching hundreds of bombers at a time. As the scale of operations grew, American commanders adapted their tactics, using staggered formations, improved radio coordination, and better route planning to tighten formation defenses and increase bombing accuracy. Slowly, the U.S. Air Force learned to fight and survive in one of the deadliest battle zones in the world. German leaders closely monitored the results of each raid, and while they publicly projected confidence, internal reports revealed growing anxiety. Even when bombing accuracy faltered, the scale of American attacks forced factories to disperse production, relocate machinery, and rebuild damaged facilities under constant threat of further strikes. This disruption strained labor resources and slowed output at a moment when the Eastern Front was consuming men and material at a catastrophic rate. Albert Speer, Germany's armaments minister, realized with alarm that the United States was escalating far faster than German defenses could adapt. Although the Luftwaffe inflicted heavy losses, it was losing experienced pilots faster than it could replace them, a trend that would only intensify as American operations gained momentum. Meanwhile, intelligence teams in England continued refining target lists with almost scientific precision. They used reconnaissance photographs to identify bottlenecks, sections of rail lines without alternative routes, power stations that fed multiple factories, and chemical facilities essential for synthetic fuel production. Every mission, even those that appeared unsuccessful, yielded data that improved the next raid. Analysts realized that the key to crippling the Ruhr was not necessarily flattening entire complexes, but hitting specific components: compressor hulls, powerhouse sections, blast furnaces, and switchyards. Strategic bombing was becoming more sophisticated, more focused, and more tied to a deep understanding of Germany's industrial anatomy. By the end of 1943, it was clear that the United States had crossed a threshold. The early phase of symbolic raids was over. The strategic bombing campaign had become a grinding, methodical effort to dismantle the Nazi war machine through sheer persistence and analytical precision. The bombers still lacked long-range escorts capable of protecting them deep inside Germany, and losses remained dangerously high. But the doctrine forged in American classrooms and tested in the skies above Europe was maturing into a formidable instrument of war. The next stage of the air campaign would escalate even further, culminating in operations that pushed American air power to its breaking point, and, ultimately, reshaped the fate of the war. By the spring of 1943, American air power faced the defining challenge that strategists had predicted but few had fully comprehended: the need to push beyond coastal targets and strike deep into Germany, where the true lifeblood of Hitler's war machine pulsed within vast industrial complexes. The Luftwaffe had anticipated this escalation, reinforcing the skies over the Ruhr Valley with layers of radar, flak towers, searchlights, and elite fighter wings. To reach these targets, American crews would be forced to cross hundreds of miles of enemy territory, endure continuous waves of attack, and maintain formation a full hour or more inside clouds of flak that turned the sky into a black, boiling sea. These missions marked a new phase of the air war. No longer symbolic probing strikes, but deliberate blows aimed at crippling Nazi industry at its core. The Ruhr, often called Germany's industrial black country, was a fortress of steel, smoke, and fire. It produced the coal, iron, machinery, and armaments that sustained Hitler's armies, and German planners understood that its destruction would be catastrophic. As a result, the region was one of the most heavily defended airspaces on Earth. Anti-aircraft guns the size of naval cannons lined the valleys, guided by sophisticated fire control systems that adjusted for altitude, wind, and bomber speed. When American formations entered the region, flak gunners unleashed dense barrages that formed towering walls of black bursts, each explosion capable of shredding a bomber's aluminum skin or sending shrapnel ricocheting through bomb bays and fuel tanks. To survive, these missions required not just courage, but perfect discipline and unbroken formation integrity. The first major American raids into the Ruhr revealed the staggering difficulty of executing daylight precision bombing on such heavily defended targets. Even with advanced Norden bomb sights, bombardiers struggled to see through the thick haze of industrial smoke, artificial fog generated by German defenses, and the perpetual cloud cover that hung over the region. Some bombs fell short, others scattered wide, planes drifted in turbulent winds, and the Luftwaffe attacked with relentless ferocity. German fighter groups, flying Bf-109s and Fw-190s, coordinated their assaults with radar-guided timing, diving through formations with cannons blazing, then climbing back into the sun to strike again. The Americans soon realized that these missions pushed the limits of what unescorted bombers could endure. Yet despite brutal losses, the raids began to show that American air power possessed a resilience that surprised even seasoned RAF veterans. B-17s returned to England with wings shredded like fabric, control cables severed, and engines barely turning, but still managing to skid onto runways or crash land in fields. Crews staggered out, frostbitten, bleeding, exhausted, but alive. Each returning aircraft carried the marks of survival stories that defied logic. These battered bombers became symbols of the air campaign's grim determination, inspiring hope among the Allies that the Nazi industrial base could indeed be reached and struck. The photographs from these missions, though blurry and blackened by smoke, revealed something strategically important. Even partial hits on Ruhr targets disrupted production more severely than anyone had expected. American planners recognized that success in the Ruhr demanded not only courage but overwhelming mass. More planes, larger formations, tighter coordination, and continuous strikes that prevented German industry from recovering between raids. Production lines in the United States were accelerating rapidly, delivering bombers at a pace no other nation could match. New airfields were completed every month across England, and the 8th Air Force expanded from small, tentative groups into vast wings capable of launching hundreds of bombers at a time. As the scale of operations grew, American commanders adapted their tactics, using staggered formations, improved radio coordination, and better route planning to tighten formation defenses and increase bombing accuracy. Slowly, the U.S. Air Force learned to fight and survive in one of the deadliest battle zones in the world. German leaders closely monitored the results of each raid, and while they publicly projected confidence, internal reports revealed growing anxiety. Even when bombing accuracy faltered, the scale of American attacks forced factories to disperse production, relocate machinery, and rebuild damaged facilities under constant threat of further strikes. This disruption strained labor resources and slowed output at a moment when the Eastern Front was consuming men and material at a catastrophic rate. Albert Speer, Germany's armaments minister, realized with alarm that the United States was escalating far faster than German defenses could adapt. Although the Luftwaffe inflicted heavy losses, it was losing experienced pilots faster than it could replace them, a trend that would only intensify as American operations gained momentum. Meanwhile, intelligence teams in England continued refining target lists with almost scientific precision. They used reconnaissance photographs to identify bottlenecks, sections of rail lines without alternative routes, power stations that fed multiple factories, and chemical facilities essential for synthetic fuel production. Every mission, even those that appeared unsuccessful, yielded data that improved the next raid. Analysts realized that the key to crippling the Ruhr was not necessarily flattening entire complexes, but hitting specific components: compressor halls, powerhouse sections, blast furnaces, and switchyards. Strategic bombing was becoming more sophisticated, more focused, and more tied to a deep understanding of Germany's industrial anatomy. By the end of 1943, it was clear that the United States had crossed a threshold. The early phase of symbolic raids was over. The strategic bombing campaign had become a grinding, methodical effort to dismantle the Nazi war machine through sheer persistence and analytical precision. The bombers still lacked long-range escorts capable of protecting them deep inside Germany, and losses remained dangerously high. But the doctrine forged in American classrooms and tested in the skies above Europe was maturing into a formidable instrument of war. The next stage of the air campaign would escalate even further, culminating in operations that pushed American air power to its breaking point, and, ultimately, reshaped the fate of the war. American air power reached a new level of sophistication in 1943 as U.S. engineers refined every part of the strategic bombing system, from Norden bombsight calibration to high-altitude engine performance. Factories in Detroit, Seattle, and California produced aircraft not as individual machines, but as components of a vast industrial ecosystem, each bomber built with precision tolerances previously unimaginable in wartime manufacturing. Crews trained relentlessly to master formation flying, oxygen management, radio discipline, and fuel balancing. By the time these units crossed the Atlantic, the American bomber force was no longer an experiment. It was an airborne machine of industrial strength and scientific calculation, designed to hit Germany's war-making heart with devastating accuracy. The Luftwaffe quickly learned that the U.S. approach to air warfare differed fundamentally from Britain's. American daylight raids were not simple shows of force. They were mathematically planned assaults aimed at severing vital arteries of Hitler's economy. U.S. intelligence teams compiled vast libraries of reconnaissance photos, analyzing the shadows, roof shapes, and traffic patterns of German industrial zones. When a target was approved, it was assigned not just a point on a map, but an economic rationale. How many tanks would be lost if this bearing factory fell? How many aircraft Germany couldn't produce if this aluminum plant stopped running? Every bomb load had a strategic purpose. Every crew member understood that they were not just attacking buildings. They were attacking the ability of a regime to wage war. But precision bombing came at a brutal cost. The first deep penetration missions into Germany tested the limits of courage, physics, and endurance. Frostbite could cripple a gunner's hands within minutes at 25,000 feet. Engines burned oil at high altitude, poisoning the cabin with fumes. Turbulence slammed the aircraft violently as they crossed the jet stream, and flak blossoms ripped open the sky like iron flowers exploding with razor-sharp petals. Crews watched entire bombers fall in slow, sickening spirals, yet they stayed in formation, knowing the mission depended on discipline. These early raids were both a scientific triumph and a human trial by fire. As the air campaign expanded, American strategists confronted a crucial dilemma. whether to attack German cities broadly or target the underlying systems that powered the Nazi military. Ultimately, the U.S. chose to dismantle specific pillars of the war machine: ball bearings, synthetic fuel, aircraft plants, rubber refineries, and transportation networks. This approach required extraordinary intelligence work. Photo interpreters at RAF Medinum, working with their American counterparts, became the unseen backbone of the entire air war. They pored over millions of images with magnifying lenses, identifying hidden dispersal sites, camouflaged workshops, and decoy buildings. These analysts, many of them young women, provided the map of German industrial anatomy that American bombers would later tear apart. By late 1943, the United States began deploying new tools that radically changed the balance of the air war. The P-51 Mustang, equipped with long-range drop tanks, became a guardian angel for bomber crews, sweeping ahead, behind, and above the formations with newfound dominance. Radar-guided navigation systems allowed bombers to maintain cohesion even through thick cloud cover. Improved incendiaries and delayed fuse bombs enabled deeper penetration into industrial complexes. Germany had once relied on poor weather to hide its factories. Now the Americans could bomb through storms, fog, and nightfall. Air power was becoming not just a force, but a constant presence that Germany could no longer escape. Germany responded with desperation. Albert Speer ordered factories moved underground, some carved into mountains, others hidden in forests or railway tunnels. Workers labored by candlelight beneath layers of rock as bombs thundered overhead. The Luftwaffe reallocated fighters from the Eastern Front, weakening ground operations against the advancing Soviets. Fuel shortages forced pilots to ration flight hours, reducing the training pipeline and sending inexperienced flyers into combat against increasingly skilled American crews. Every adjustment Germany made revealed the strain of fighting a technologically superior enemy whose industrial power seemed bottomless. As 1944 progressed, American air power began to achieve what had once been considered impossible, breaking the industrial backbone of a nation at war. The synthetic fuel campaign hit Germany with surgical brutality, collapsing an industry it had spent years constructing. Without fuel, tanks could not reach the front. Fighters could not intercept bombers. Trucks could not supply divisions. The airfields became graveyards of grounded aircraft, their pilots stranded as the strategic bombing system tightened its grip. For the first time, the Luftwaffe was not merely outnumbered. It was running out of the very lifeblood of mechanized warfare. By the time Allied ground forces crossed into Germany, the air war had already hollowed Hitler's war machine from within. Bridges, rail yards, factories, refineries, and supply lines lay in ruins. What ground troops faced was not the unstoppable Wehrmacht of 1940, but a depleted, exhausted army starved of fuel, transport, replacements, and air cover. American air power had done more than destroy targets. It had reshaped the very trajectory of the conflict, altering the timetable of the invasion and accelerating the collapse of the Nazi state. The skies over Europe had become the crucible in which Hitler's war machine was broken, one strike at a time. As 1944 dawned, the air war over Europe entered its most decisive phase, driven by a new philosophy of overwhelming, relentless aerial pressure. U.S. commanders recognized that Germany could no longer be attacked in isolated blows. Instead, the enemy's industrial system had to be assaulted in synchronized waves, hitting production, transportation, fuel, and repair facilities so quickly that recovery became mathematically impossible. Precision still mattered, but now it was precision at scale. Hundreds of bombers lifted off each morning in tightly orchestrated streams, each formation assigned a specific time window, altitude band, and target chain. American planners were no longer trying to break one factory at a time. They were trying to break the rhythm of German industry itself. The transportation plan became one of the most transformative elements of this strategy. Allied intelligence discovered that every German unit, whether infantry, armor, or artillery, relied overwhelmingly on railways, not trucks, to move across the Reich. If the rail grid collapsed, Germany's ability to shift divisions, evacuate factories, or reinforce critical fronts would fail with it. American bombers, guided by extensive reconnaissance, targeted marshalling yards, junctions, and locomotive depots with ruthless precision. The explosions created massive, web-like patterns of destruction, twisted tracks, cratered switching stations, and derailed freight cars that blocked entire corridors. Within weeks, rail-dependent troop movements slowed to a crawl, forcing Hitler's armies to fight increasingly isolated, undersupplied, and unable to adapt to battlefield realities. Meanwhile, the tactical air forces were growing into a force of their own, complementing the strategic bombing campaign in ways never before seen in warfare. Thunderbolts and Mustangs roamed the skies at low altitude, striking convoys, strafing columns of trucks, and destroying bridges that were vital to German maneuverability. American pilots became experts in quick-hit assaults, diving from the sun, firing in short, lethal bursts, then disappearing before the enemy could react. Ground troops advancing through France and the Low Countries would later recall that they felt safer when they heard the roar of American fighters overhead. Those aircraft became the constant guardians of Allied movement, clearing the roads of German resistance long before tanks or infantry arrived. The results were cumulative and devastating. With transportation crippled, fuel supplies collapsing, and aircraft production shattered, the Luftwaffe lost its ability to contest the skies. Even newly produced fighters sat useless on runways, grounded by empty fuel tanks or lacking trained pilots. Hitler's once feared air force, which had terrorized Europe in 1940, now resembled a broken shell, scattered, starved, and increasingly invisible. American bomber crews noticed the change. Missions that had once been gauntlets of constant fighter attacks were now dominated by flak alone. The sky was no longer a battlefield of equal adversaries. It was becoming an arena of Allied dominance. Yet the collapse of German air defenses did not mean the missions became easy. Flak remained a lethal threat, and as air superiority slipped away, German gunners grew even more determined. Cities like Berlin, Hamburg, and Munich bristled with anti-aircraft emplacements, creating towering walls of explosive steel that bombers had to fly through to reach their targets. The courage required for these missions remained enormous. Crews later described the sky as a storm made of metal, a place where every second carried the risk of catastrophic failure. But unlike earlier in the war, there was now a sense of momentum, a belief that every mission, every factory destroyed, every railway smashed, brought the conflict measurably closer to its end. American air power also evolved toward greater precision and efficiency with every passing month. Rapid improvements in targeting technology, meteorological forecasting, and high-altitude navigation made strikes more reliable even when weather conditions deteriorated. Blind bombing systems like H-2X radar allowed crews to hit industrial zones through cloud cover, denying Germany the protective cloak of bad weather. This was a profound shift. The Reich had once counted on winter storms and fog to halt Allied raids. Now, those same storms provided only temporary concealment as American bombers steadily adapted to the environment, turning the natural world from a shield into a mere obstacle. The human element remained central to this entire transformation. Thousands of analysts, engineers, mechanics, weather officers, radio operators, and codebreakers contributed to each mission, forming a vast network of expertise behind every bomb that fell. These individuals operated far from the front lines, yet their work shaped the battlefield as surely as any pilot. It was they who plotted wind speeds at altitude, identified weak points in industrial circuits, repaired engines overnight, or trained new crews in the complex art of formation flying. Their combined efforts represented the full weight of American scientific and industrial intelligence, focused like a beam of light onto the very core of the Nazi war economy. By late 1944, Germany's industrial system resembled a fractured machine, still functioning in places, limping in others, but fundamentally incapable of generating the momentum needed to sustain a modern war. Tanks rolled off assembly lines with no fuel to power them. Aircraft were delivered with no pilots to fly them. Troops waited for supply trains that would never arrive. Roads clogged with abandoned vehicles as fuel shortages paralyzed entire divisions. The collapse was not sudden. It was the result of thousands of coordinated strikes that slowly suffocated the Reich's ability to act. By late 1944, the American air campaign entered a stage that was both brutal and surgically effective, focusing on a single lifeline that determined the fate of the German war machine: oil. Every tank, aircraft, truck, submarine, and armored division Germany possessed depended on a shrinking pool of fuel sourced from synthetic production facilities and a handful of vulnerable refineries. American planners knew that if these plants were destroyed, the Wehrmacht would be rendered immobile. The attacks on places like Ploiești, Merseburg, Palitz, and the synthetic complexes at Luna became some of the most heavily defended targets in all of Europe. Crews who flew these missions faced unimaginable resistance: sky-blackening flak, piercing searchlights, and dense fighter screens. But they pressed forward again and again, tearing the heart out of the German oil network and accelerating the collapse of Hitler's military mobility. The destruction of the oil infrastructure produced effects far more dramatic than even Allied planners initially predicted. Within months, German armored divisions were rationing fuel to such extremes that tanks were ordered not to move unless absolutely necessary. Training flights for new Luftwaffe pilots were drastically curtailed, creating a generation of young, inexperienced airmen who were sent into combat with only a fraction of the preparation their predecessors had received. Entire airfields became graveyards of grounded aircraft, some pristine and newly manufactured, yet entirely useless. Mechanized units were forced to rely on horses for transport, a jarring regression that revealed how decisively the modern German war machine had been rolled back by targeted airstrikes. Even as fuel supplies dwindled, Allied air power increasingly focused on preventing Germany from repairing or reconstituting shattered infrastructure. American bombers returned repeatedly to the same industrial zones, cratering repair yards and machine shops that attempted desperately to restore production. This persistence, known as the restrike doctrine, ensured that facilities could not merely rebuild and resume operations. Every time workers cleared rubble or installed temporary machinery, another wave of bombers arrived to erase their progress. German engineers later described this as fighting a battle against time, a battle they could not possibly win as long as American bombers commanded the skies. The collapse of German oil production had profound implications for ground combat across Europe. As the Allies advanced through France, Belgium, and the Netherlands, they encountered increasingly erratic resistance. Some German units fought viciously, holding defensive positions with determination. Others found themselves immobilized, unable to maneuver, reinforce, or retreat. This inconsistency reflected the logistical chaos spreading across the Reich. The once cohesive German war machine, famous for its precision and discipline, was now fractured into pockets of improvised defense, each crippled by shortages that could be traced directly to the strategic bombing campaign. Meanwhile, the skies themselves had been transformed into a symbol of Allied dominance. American fighter pilots swept across the continent with near impunity, escorting bombers deep into enemy territory and turning any Luftwaffe attempts at resistance into lopsided duels. Even when German jets like the Me-262 appeared, their limited numbers, inexperienced pilots, and catastrophic fuel shortages prevented them from altering the balance. By this stage of the war, U.S. air power was not merely winning battles. It was reshaping the very structure of warfare, proving that control of the skies could determine the fate of armies, industries, and nations. As the bombing campaign intensified, the everyday lives of German civilians became increasingly intertwined with the war's industrial collapse. Cities that were once hubs of production, Essen, Cologne, Hamburg, Stuttgart, were turned into labyrinths of rubble and fire. Workers struggled to reach factories through devastated streets, only to find that the plants had been destroyed or relocated under conditions that made effective production nearly impossible. While the destruction generated immense human suffering, it also revealed the strategic truth that modern total war blurred the boundaries between battlefield and home front. Germany's capacity to wage war depended on its civilians as much as its soldiers, and the Allied air campaign aimed to sever that connection. The psychological impact of U.S. air supremacy was equally significant. German soldiers advancing toward the front could hear the distant drone of American bombers and know that the enemy could strike anywhere, at any time, with overwhelming force. Civilians lived in a state of constant apprehension as air raid sirens became a daily soundtrack. Letters from German officers frequently referenced the Iron Thunder overhead, endless formations of B-17s and B-24s that symbolized the unbreakable industrial might of the United States. This sense of inevitability eroded morale across the Reich, creating an atmosphere in which defeat felt less like a possibility and more like a mathematical certainty. By the end of 1944, the consequences of the air campaign were unmistakable. The German war machine, once the most formidable in Europe, had been systematically deprived of the fuel, transportation, and industrial output it needed to sustain itself. U.S. air power had not won the war alone, but it had created the conditions under which victory became possible, immobilizing divisions, grounding the Luftwaffe, crippling production, and undermining morale. What began as a risky and proven strategy in 1942 had evolved into one of the most decisive and transformative military operations in modern history, demonstrating that control of the air could break even the most powerful enemy from the inside out. By early 1945, the cumulative effects of American air power had pushed Germany into a state of irreversible military paralysis. What remained of the Reich's industrial network functioned in fragments, small pockets of production struggling to operate amid mountains of debris, fuel scarcity, and the constant threat of renewed bombardment. Even when factories attempted to disperse into forests, tunnels, or makeshift underground chambers, American reconnaissance aircraft detected them with chilling efficiency. High-altitude photo teams captured every new revetment, every camouflaged workshop, every rail spur leading to a hidden compound. These images fed directly into the Allied target system, ensuring that no attempt at concealment could last for long. The air war had become a vast cycle of detection, analysis, and destruction, operating faster than Germany could adapt. As Germany's production faltered, its frontline forces began to experience the consequences in stark, daily terms. Units defending the Western Front received fewer replacement parts, fewer shells, and fewer working vehicles. Infantry divisions were forced to fight with weakened artillery support as ammunition reserves dwindled. Tank battalions reported chronic breakdowns as spare parts vanished, leaving entire companies immobilized behind the lines. In earlier phases of the war, German engineers had been able to repair damaged armor with remarkable speed. Now, with factories wrecked and transport systems shattered, even routine maintenance became nearly impossible. Air power had created a new form of attrition, not through battlefield destruction, but through the slow starvation of the enemy's logistical lifelines. The devastation extended to the Luftwaffe's training system, which had once been one of the most advanced in the world. Without fuel or spare aircraft, flight schools operated at fractions of their former capacity. New pilots were increasingly rushed into combat with minimal training, facing American formations filled with veterans who had survived dozens of missions. The contrast was brutal. Inexperienced German pilots often lasted only minutes in the sky before being shot down. Entire squadrons were annihilated in engagements that resembled execution more than battle. The Luftwaffe, which had dominated European skies in 1940, now collapsed under the weight of operational exhaustion, industrial ruin, and unrelenting Allied pressure. Meanwhile, U.S. bombers continued to evolve into more formidable instruments of strategic warfare. Crews were now seasoned, having flown through years of combat weather, flak bursts, and relentless danger. Their ability to maintain formation under punishing conditions provided the backbone of American striking power. Many missions flew directly over the same cities and industrial hubs that had been attacked countless times before, each time deepening the structural wounds that Germany's economy could no longer heal. Engineers who surveyed the aftermath of these raids described industrial districts as open-air tombs, acres of smashed machinery, melted metal, and the skeletons of factories that had once powered the Reich's ambitions. What made the American air campaign so effective by 1945 was not merely the size of the bomber fleets, but the precision of the target selection process. Analysts worked around the clock, integrating captured documents, field reports, intercepted communications, and reconnaissance imagery into a unified picture of the enemy's remaining capabilities. This intelligence-driven approach meant that bombers were not simply dropping explosives at random. They were dismantling the logic of German warfare itself. When oil was identified as the Reich's most critical vulnerability, bombers concentrated on synthetic plants. When rail networks became the focus, transportation hubs were systematically erased. When tank production threatened to surge in late 1944, assembly centers like Kassel and Nuremberg were struck again and again. Every action was calibrated to ensure maximum disruption with minimum waste. On the psychological front, the sustained presence of American aircraft became a symbol of inevitability. Many German soldiers wrote in their diaries that they could not remember a single day without the sound of engines crossing overhead. The skies, once a domain of German dominance, had transformed into a projection of Allied power, a constant reminder that the Reich was losing control of both its territory and its destiny. Civilians, too, began to sense the war's direction. Long lines formed for dwindling supplies. Bombed-out districts grew into entire neighborhoods. The visual landscape of Germany, marked by ruins, smoke columns, and shuttered factories, reflected a nation collapsing under the weight of industrial suffocation. The final months of the air campaign revealed the limits of endurance for any industrialized state. Germany attempted desperate measures to prolong the war, dispersed factories, makeshift fuel alternatives, crash programs for new weapons, but none could overcome the sheer scale of American production and aerial supremacy. Every hour, new waves of bombers were armed, fueled, and launched from English and Italian bases, their sorties synchronized to ensure constant pressure. Hitler had once believed that industrial might alone could not win a war, yet he now faced an opponent whose industrial might combined with air power made resistance strategically impossible. As the ground forces of the United States, Britain, and the Soviet Union advanced from all directions, American air power continued to hammer the Reich's dwindling ability to resist. Rail choke points were cut, bridges collapsed, fuel depots incinerated, and troop movements interdicted before they could reach the front. The sky had become the decisive theater of the war, shaping every battlefield, every supply line, and every strategic decision. By the spring of 1945, Germany was not simply losing, it was disintegrating. And at the center of that disintegration stood the relentless, coordinated, and scientifically executed power of American air warfare, proving beyond doubt that control of the air could shatter even the mightiest war machine ever built. By the spring of 1945, what remained of Nazi Germany's war industry was crippled beyond repair, yet American Air Command refused to relent. Every production center, transportation hub, fuel depot, and command node still standing became a target. Bombers thundered over wrecked cities, dropping their loads not out of revenge, but out of necessity to prevent any last-minute resurgence. The aim was total denial. Germany should have no capacity, industrial, logistical, or psychological, to resist the advancing Allied armies. The sky became a constant hammer pounding at the skeleton of a once mighty war machine, and its blows fell without mercy. Many of the final missions involved symbolic yet strategic strikes, destroyed Gestapo headquarters, bombed communication centers, and incinerated stockpiles of ammunition and fuel. These raids didn't just target infrastructure, they targeted the capacity for organized resistance and prolongation of war. Cities like Dresden, though embroiled in controversy, served as grim reminders that the aerial arsenal of the Allies could reach any corner of the Reich. Rail lines, bridges, and supply dumps that German troops used to regroup or retreat were systematically erased. The collapse was not a sudden explosion. It was a carefully optimized decline, accelerated by a network of air raids that severed lifelines and eradicated hope. As Allied ground forces penetrated deeper into German territory, they encountered units that lacked ammunition, fuel, even food. Tiger tanks lay stranded near ruined refineries. Divisions marched on foot after their transport trucks were destroyed in air raids. Airfields lay silent, stripped of fuel or aircraft. The contrast with 1940, when the German military rolled across Europe with machine gun discipline, was striking and tragic. The Wehrmacht that fought in April 1945 resembled a skeleton of its former self, deprived not by battlefield defeats alone, but by an air campaign that had choked its veins, crippled its heart, and burned its lungs. The psychological collapse within Germany was as destructive as any bomb. Civilians, long accustomed to blackout curtains and rationing, now faced a constant aerial presence overhead. Factories were gone, neighborhoods destroyed, and the possibility of rebuilding seemed remote. Letters from German soldiers to home, intercepted by Allied intelligence or later discovered in captured archives, expressed fears not of death, but of a world no longer worth defending, a nation whose infrastructure, economy, and spirit had been dismantled airstrike by airstrike. The destruction of the homeland undermined morale far more effectively than any battlefield defeat could. In the skies above a defeated Europe, American crews flew not only to destroy, but also to deliver. Transport planes carried food, medical supplies, and relief to liberated regions. Reconnaissance flights mapped destroyed cities and infrastructure, preparing the way for rebuilding efforts. What had once been instruments of war became tools for reconstruction. The same industrial and organizational network that had forged bombers now facilitated humanitarian missions, repurposing the air arm from extermination to preservation. The war machine that built devastation now helped build recovery. Back in the United States, production plants never fully slowed down. Even as the need for bombers diminished, factories retooled to produce transport planes, cargo aircraft, and supplies for reconstruction. Engineers who had worked on bombers now applied their skills to peacetime projects, rebuilding Europe, supporting displaced populations, and restoring global stability. The industrial infrastructure that had sustained war thus became the foundation for peace. This smooth transition demonstrated how deeply the wartime air economy had integrated into national purpose, from destruction to reconstruction, without skipping a beat. The legacy of the air campaign left an indelible mark on military doctrine. The success of strategic bombing reinforced the notion that air power could determine the outcome of total war, influencing post-war planning, military budgets, and the structure of air forces worldwide. Airborne early warning, strategic reconnaissance, long-range bombers, and transport fleets became cornerstones of future defense strategies. The idea that wars could be won or lost in factories and skies became accepted doctrine, and the scale of industrial mobilization and air power coordination established during World War II shaped global military thinking for decades to come. Ultimately, the surrender of Germany in May 1945 was as much the result of skies filled with American bombers as of boots on the ground. The Reich fell not only because its armies were defeated, but because its capacity to wage war was dismantled from the air, layer by layer, strike by strike. The collapse was comprehensive, economic, logistical, psychological, and it unfolded across months of relentless aerial pressure that Germany could not counter. The skies, once weapons overhead, had become weapons of fate. The war ended not with a single battle, but with the steady destruction of an entire war machine, proving that in total war, control of the skies could reshape history. By early 1944, as American factories reached a level of synchronized efficiency unmatched in modern history, one product emerged as the clearest symbol of U.S. industrial might: the medium tank. From Detroit to Chicago to Grand Blanc, steel mills glowed day and night, feeding an uninterrupted stream of armor plates, drive trains, and cast turrets into assembly lines that had matured from experimental chaos to something approaching mechanical symphonies. The American tank had become not merely a weapon but a demonstration of what coordinated production, abundant raw materials, and relentless engineering refinement could achieve. While no single plant defined the effort, Detroit Arsenal Tank Plant stood as the towering emblem of this transformation, a place where the thunder of presses and welding torches echoed a national determination to push back the Axis at any cost. Yet the story of American tank production was not just deterministic triumph. It was born from harsh lessons in North Africa, where early combat exposed flaws that no amount of patriotic optimism could gloss over. Reports flowed back to Washington: inadequate armor in some sectors, ammunition storage prone to ignition, engines struggling with desert conditions. Instead of dismissing these as inevitable wartime losses, American engineers and factory managers treated each failure as actionable data. Workshops inside the plants, staffed by draftsmen who often had never seen a battlefield, became rapid response units, tearing down hulls, modifying turrets, adjusting suspension systems, and inventing new armor configurations on timelines thought impossible before the war. Now, feedback loops linked frontline combat to factory workstations with unprecedented speed, accelerating innovation and transforming American tanks into something far more formidable by the time the Allies returned to Europe. Inside the tank plants themselves, the operational choreography was nearly miraculous. Massive steel plates crept along overhead cranes, lowered onto chassis like tectonic slabs settling into place. Sparks showered from teams of welders who moved in precise, trained patterns that resembled industrial dance. Inspectors in hard hats and heavy coats tapped armor joints with brass hammers, listening for tonal inconsistencies that betrayed hidden flaws. And at the far end of these vast halls, engines were fired for the first time, filling the plant with a low, vibrating growl that seemed to tremble in the workers' bones, a sound that many would later describe as the heartbeat of America's industrial war effort. Every hour, another tank rolled out of the gates. Every shift, another platoon's worth of armored power was born. What made this surge extraordinary was the degree to which American manufacturing could reshape itself in real time. Factories originally designed for automobiles or farm equipment were reconfigured with astonishing flexibility. At Chrysler's converted facilities, stamping machines once dedicated to car fenders now shaped armored hull components. In one corner of the plant, former auto upholsterers stitched padded seats for tank interiors. In another, machinists who had spent their careers making engine blocks for sedans now milled precision gear sets capable of enduring battlefield punishment. Industrial America, far from being rigid or slow to adapt, demonstrated an agility that stunned even seasoned military planners. The logistics feeding these plants were equally staggering. Rail cars loaded with iron, ore, coal, and industrial alloys snaked across the country in mile-long chains. Chemical plants supplied lubricants, hydraulic fluids, and rubber compounds essential for tracks and seals. Electrical manufacturers delivered intricate wiring harnesses and communication systems. This ecosystem of suppliers, thousands of firms, many of them small businesses operating far from the spotlight, formed the circulatory system that sustained tank production. Without them, the great factories would have been powerless. With them, they became unstoppable engines of output. By the time these perfected machines reached Europe, their presence was immediately felt. Though heavier German armor often boasted thicker plating or more powerful guns, American tanks excelled not in isolated duels, but in strategic ubiquity. They were everywhere, streaming across France, maneuvering through Belgium, storming across the Rhine. Their reliability meant fewer breakdowns. Their numbers ensured constant pressure. Their mobility enabled combined arms tactics that defined the final phase of the European campaign. American production did not seek to match Germany tank for tank in a narrow technical contest. It overwhelmed the battlefield with sheer logistical superiority, a philosophy born directly from the principles guiding the arsenal of democracy. At home, workers followed every development closely. Plants posted maps with colored pins showing where their tanks had been deployed. Notices from the War Department highlighted achievements, such as the 1,000th tank shipped overseas, sparking celebrations on factory floors. Families clipped newspaper photos of armored units moving through liberated towns, circling identification markings they recognized from their own plant's paint bay. These emotional connections mattered deeply. They transformed a grueling industrial effort into something personal, a sense of shared ownership in the liberation of Europe and the defeat of tyranny. By the end of the war, American tank manufacturing had produced not only weapons but a blueprint for modern industrial power. The lessons learned about integrated supply chains, rapid engineering cycles, synchronized labor divisions, and adaptive conversion would reshape civilian manufacturing for decades. More importantly, the tanks themselves came to symbolize something beyond steel and firepower. They represented a nation's determination, expressed not through conquest but through unrelenting production. The idea that democratic societies, when united in purpose and supported by vast industrial capability, could outbuild and outlast the darkest ambitions of authoritarian power. The factories had done more than produce war machines. They had forged the tools of liberation. Across the European continent in 1944, as the Allies pressed deeper into territory once considered impenetrable, The construction of forward airfields became one of the most decisive, yet least celebrated, feats of the American war effort. In the wake of every advance, engineer battalions swarmed over liberated land, transforming battered farmland and cratered clearings into operational runways within days. Their work was not improvisational chaos, but the culmination of years of meticulous planning inside American industrial and engineering circles, which had anticipated the need for rapid deployment of air power as the spear point of the Allied offensive. The materials, machinery, and prefab structures that enabled this miracle had been quietly produced by hundreds of American factories whose output now shaped the very geography of the war. What made these airfields revolutionary was the technology behind them, especially the invention and mass production of perforated steel planking. Known colloquially as Marston mats, these steel panels interlocked like giant metallic puzzle pieces, forming durable runways over soft mud, snow, or uneven terrain. American steel plants had produced millions of these panels, their stamping presses pounding day and night until the sound became a constant industrial heartbeat. Each mat, though unremarkable in isolation, contributed to a system capable of sustaining the weight of fully loaded bombers and fighter planes. Without these mats, many of the airfields that supported the breakout from Normandy would have been impossible, and the pace of the Allied advance would have slowed to a crawl. The construction of these airfields was itself a spectacle of controlled urgency. Bulldozers roared across fields still littered with debris from retreating Axis forces. Surveyors paced quickly across open ground, their calculations dictating the future arcs of incoming and outgoing aircraft. Fuel trucks, still warm from their transatlantic transport, pulled into provisional depots where crews established makeshift distribution systems using equipment designed months earlier by stateside manufacturers who understood that mobility would define the European campaign. Every hour shaved off construction meant more sorties flown, more ground troops supported, more pressure applied on a collapsing enemy. At the heart of this effort was a logistical marvel that few civilians ever saw: the airborne supply chain. American factories produced not just the physical components of airfields, but the vehicles, tools, and modular structures that allowed engineers to create functioning bases almost anywhere. Prefabricated control towers arrived in crates, ready to be bolted together. Communications equipment, radio gear, windsocks, and radar units streamed in by the thousands. Even the humble nails and screws used in temporary barracks were standardized and mass-produced, ensuring that construction teams could work without hesitation or shortage. This material abundance stood in stark contrast to the increasingly strained German supply system, which struggled to maintain even basic defensive infrastructure. Once operational, these American-built airfields became the connective tissue of the Allied bombing campaign, allowing fighters and bombers to operate with a degree of reach and responsiveness the Axis had never anticipated. Medium bombers launched deep into Germany from improvised runways barely a week old, while fighter escorts now enjoyed a proximity to their missions that dramatically reduced losses. The Luftwaffe, already weakened by attrition, could no longer rely on long distances to slow Allied raids. Every new airfield that appeared on the map tightened the noose around Germany's industrial centers, transportation hubs, and defensive lines, accelerating the collapse of its war-making capability. For the ground troops, the sight and sound of these newly established air bases offered reassurance that the front line was not isolated. Soldiers spoke of hearing the constant hum of engines at dawn and feeling both protected and empowered. Each takeoff symbolized momentum. Each landing signaled reinforcements, supplies, and the unbroken link between the battlefield and the vast American industrial machine across the ocean. The airfields became symbols of Allied permanence, visible proof that the forces pushing eastward were not temporary intruders, but the leading edge of an unstoppable tide. For the populations of liberated towns, the arrival of American airfield crews carried profound emotional significance. They watched as foreign soldiers, many barely older than the children peering from windows, labored to carve runways out of shattered terrain. To villagers who had lived under occupation for years, the sight of American planes rising into the sky seemed to mark the return of freedom itself. Some locals even joined the effort, helping clear rubble or carrying tools, eager to participate in rebuilding what had been destroyed. Photographs from the period show civilians standing proudly beside engineers, sharing the moment when barren ground first began to resemble an outpost of hope. By late 1944, the network of Allied airfields across France, Belgium, and the Netherlands had become one of the greatest operational advantages in modern warfare. It allowed the seamless flow of fighter cover, reconnaissance missions, medical evacuations, airborne resupply, and the sustained bombing of Germany's last industrial bastions. The speed and scale of these achievements were not accidents, but deliberate outcomes of American industrial foresight and engineering innovation. In effect, U.S. industry had not only armed the skies, it had built the very platforms from which victory could be launched. Far behind the front lines, yet indispensable to every mission flown, were the sprawling American repair depots, vast complexes of hangars, machine shops, and testing grounds where damaged aircraft were reborn. These centers, often scattered across England and later established on the continent itself, represented an industrial war within the war. Night after night, transport vehicles delivered bombers and fighters shot up over Europe, their fuselages torn by flak, engines scorched, windows shattered, and wings pitted with dozens of holes. What emerged weeks, or even days later, were fully restored aircraft, painted fresh, engines tuned, and systems recalibrated with a precision that matched the original factory specifications. It was here, amid the smell of oil and the echoing clang of metal, that American air power sustained its continuity. These repair depots functioned because U.S. industry had anticipated the need for battlefield-ready production long before the invasion of Europe. Factories in the United States manufactured replacement parts in numbers that defied calculation. Carburetors by the tens of thousands, propeller assemblies lined up like metallic forests, landing gear components packed into crates towering in warehouses. Every rivet, every electrical relay, every oxygen valve was engineered to be interchangeable across multiple aircraft models, a revolutionary concept at the time. This standardization meant that a bomber with shattered hydraulics or a fighter missing half its control surfaces could be repaired using parts from a supply chain that was effectively endless. Without this industrial foresight, the European air fleets would have dwindled long before reaching the decisive phase of the conflict. Inside the depots, the work unfolded with a rhythm that blended urgency and technical mastery. Teams of mechanics crawled over aircraft like surgeons over wounded patients, tracing damage back to its root cause. Some coordinated the delicate task of replacing entire wing sections, guiding cranes with hand signals while standing atop makeshift scaffolding. Others repaired bullet-riddled fuselages, hammering sheet metal into perfect alignment before securing each new panel with hundreds of rivets fired from pneumatic guns that chattered like machine pistols. Nearby, engine specialists dismantled entire power plants, laying out pistons, gaskets, and bearings in long, methodical rows before rebuilding them with the care of master artisans. These were not simple technicians. They were craftsmen operating on a scale and under pressures no civilian garage could ever imagine. Beyond the physical repairs lay the equally critical realm of testing and calibration. Aircraft emerging from the shops were not returned to service until they had undergone rigorous ground and flight testing. Engines were run on test stands, their vibrations analyzed with the precision of medical diagnostics. Electrical systems were meticulously checked, radios tuned across every channel, oxygen systems purged and recharged. Some airfields even had short runways dedicated exclusively to post-repair test flights, where pilots, many of whom volunteered for the hazardous duty, evaluated responsiveness, stability, and emergency systems. These pilots developed a near-spiritual rapport with the machines they flew, trusting the mechanics who had rebuilt them and understanding that their assessments could determine the survival of entire bomber crews. The human element of these depots was marked by a quiet heroism rarely captured in wartime narratives. Many workers were older men, factory veterans considered too old for combat, but invaluable for their technical experience. Others were young recruits who had never imagined a life surrounded by aircraft, but who adapted with astonishing speed, learning to diagnose electrical faults or engine issues under the glow of dim workshop lamps. Women played a vital role as well: radio technicians, precision assemblers, machinists, whose work ensured that complex systems performed flawlessly at 25,000 feet. Even though they served far from the front, these individuals felt the war's weight intimately. Every repair completed was a life-protecting act. Every delay could mean a crew never returning from a mission. It was in these depots that the tangible consequences of air combat were encountered most directly. Mechanics often found fragments of flak embedded in wings, dents from cannon rounds, or torn metal edges that hinted at moments of terror experienced above the clouds. Crews returning damaged planes sometimes visited the repair shops to share what had happened, how a sudden burst of flak had knocked out hydraulics, how a fighter attack had shredded an elevator, how the crew had held the aircraft aloft by improvisation and sheer will. These stories infused the repair work with emotional gravity. Mechanics knew that the next time the aircraft took off, the men inside were trusting their work with their lives. As the war progressed, the scale of these operations grew even greater. Depots in England expanded into small cities of steel and concrete, with their own power stations, mess halls, and living quarters for the thousands who sustained the air war. After the liberation of France, advanced repair units moved onto the continent, establishing mobile depots closer to the front. This reduced turnaround times and allowed damaged aircraft to return to the fight within days instead of weeks. The mobility of these depots reflected the flexibility of American logistics, a hallmark of U.S. industrial planning that transformed static support systems into dynamic, frontline assets. By 1945, these repair centers had become indispensable pillars of Allied air dominance. Their technicians ensured that the skies remained filled with operational bombers and fighters, turning what could have been a war of attrition into a relentless offensive. Germany, lacking an equivalent network and struggling under bombing devastation, could not keep pace. In the end, the quiet excellence of these repair crews, supported by the limitless American industrial engine, helped maintain the tempo of the air campaign until the very last days of the conflict. They proved that victory was not only won in the air, but also in the hangars, workshops, and depots where damaged aircraft were given a second life. Long before each bombing raid thundered toward its target, a quieter, far more complex battle unfolded in shadowed rooms where intelligence officers, reconnaissance pilots, and photo interpreters worked to decode the enemy's industrial lifelines. American air power did not operate blindly. Every strike was the final link in a chain of analysis stretching from laboratories in the United States to makeshift intelligence huts on British airfields. It was here, surrounded by maps, blueprints, intercepted communications, and reconnaissance prints the size of tabletops, that analysts pieced together Germany's shifting war economy. Their goal was not merely to know where factories stood, but how they functioned, what they produced, which rail lines fed them, and how quickly they could recover from damage. By the final year of the war, this intelligence network had become a weapon every bit as potent as the aircraft it guided. The backbone of this intelligence effort was aerial reconnaissance, high-altitude missions flown by unarmed or lightly armed aircraft carrying specialized cameras capable of capturing entire cities in a single frame. Pilots flew alone or in pairs, often racing at the upper limits of altitude to avoid flak and fighters, relying on speed and surprise rather than force. When these aircraft returned, the film rolls were rushed to darkrooms where technicians worked in near silence. Minutes later, long strips of photographic negatives revealed factory complexes, rail yards, fuel depots, and defensive installations with stunning clarity. In these aerial mosaics, analysts could detect the faintest signs of German reconstruction: fresh concrete, uncamouflaged structures, new craters being filled, rail spurs repaired overnight. From these photographs emerged a sophisticated understanding of Germany's industrial anatomy. Analysts learned to distinguish operational facilities from decoys, to trace the directional flow of supply chains, and to read shadows and smoke patterns to determine which buildings housed critical machinery. They analyzed power station outputs by measuring the density of steam plumes and tracked oil refinery recovery by the presence of new storage tanks. The precision with which the Allies mapped these developments allowed them to strike at Germany's industrial heart with unparalleled accuracy. Factories weren't just bombed, they were diagnosed, dissected, and neutralized based on an evolving picture constructed by thousands of reconnaissance images. Signals intelligence added another layer to this effort. American and British codebreakers intercepted German military communications, message traffic between industrial officials, and logistical instructions sent across the Reich. Many of these messages were broken with astonishing speed, thanks to the cryptanalytic machines developed in the US and Britain that could process cipher patterns faster than any human. These decoded signals revealed information that even aerial photography could not capture: production schedules, relocation plans, shortages of skilled labor, and frantic attempts by German officials to reroute supply chains after major strikes. In effect, the Allies watched the German war machine struggle to adapt in real time, and struck again whenever recovery seemed possible. The interaction between intelligence and air commanders became the engine of strategic bombing. Debriefings after each mission fed new data into the analytical cycle, creating a dynamic feedback loop. Reconnaissance units were assigned to fly over recently bombed targets within hours, allowing analysts to measure the exact effect of each raid. Did the refinery fire burn hot enough to destroy cracking units? Did the rail yard remain paralyzed after the night's bombing? Had dispersal sites sprung up in nearby forests to protect aircraft production? This continuous assessment allowed mission planners to shift targets swiftly, ensuring that resources were never wasted on already destroyed facilities and that the Luftwaffe could not regain strength through rapid repair. The intelligence war was not without its own hazards. Reconnaissance pilots often flew far ahead of friendly lines, isolated and vulnerable. Many never returned. Their sacrifices, though less publicly celebrated than those of bomber crews, carried immense strategic consequence. A single reconnaissance flight could reveal the relocation of a major aircraft plant or the emergence of new synthetic fuel sites. Such discoveries frequently reshaped entire bombing campaigns. Every photograph retrieved, every message decrypted, every industrial map updated became a silent victory, one that saved thousands of Allied lives and hastened the collapse of German capability. As the Allies advanced across Europe, intelligence teams moved with them, establishing forward analysis centers in liberated towns and villages. These mobile units often operated from hastily converted schools or barns, powering their equipment with generators hauled over broken roads. Inside these makeshift centers, analysts worked through piles of reconnaissance imagery covering Germany's shrinking industrial zones. With each passing week, the maps on their walls grew smaller as enemy territory contracted, revealing the crumbling core of a war machine increasingly unable to hide its vulnerability. By 1945, intelligence officers could predict the collapse of entire industrial sectors before they occurred, reading the signs of exhaustion in Germany's dwindling output, fuel shortages, and deteriorating transportation network. In the end, the intelligence war above the clouds proved indispensable to the success of American air power. It ensured that the relentless aerial offensive was not blind force but targeted, evolving, and strategically precise. Rather than scattering bombs across a continent, the Allies directed their power with surgical intent, crippling synthetic fuel plants, obliterating aircraft factories, shutting down transportation arteries, and draining the lifeblood of the Luftwaffe. Through the silent labor of analysts, codebreakers, reconnaissance crews, and engineers, the U.S. transformed information into a weapon as decisive as any bomb. And as Germany's war machine buckled under this dual assault of intelligence and air power, the ultimate truth of modern warfare became undeniable. Wars could now be shaped not only by strength, but by knowledge. By the spring of 1945, the culmination of American industrial might, strategic planning, and relentless air power became undeniable. Across Europe, the Reich lay in ruins, not just physically, but economically, logistically, and psychologically. Factories lay shattered, rail networks severed, and fuel depots consumed by fire. The Luftwaffe, once a dominant aerial force, had been reduced to a shadow of its former strength, its remaining aircraft scattered and its pilots exhausted. The relentless integration of production, intelligence, and operational air campaigns had transformed what could have been a long war of attrition into a swift collapse, demonstrating the unparalleled power of a nation capable of mobilizing industry on a massive scale. On the ground, Allied armies advanced into territory where cities still smoked from bombing raids. Soldiers and civilians alike witnessed the aftermath of American air supremacy, flattened industrial zones, derailed trains, and empty factories. Yet the true genius of the strategy lay not only in destruction, but in prevention. By crippling Germany's industrial heart, the Allies denied the Axis the resources to regroup, counterattack, or sustain morale. American bombers, armed with intelligence and reinforced by the logistical networks back home, had achieved something unprecedented, shaping the outcome of a war before the enemy even had the chance to react fully. The orchestration of this victory required more than weapons and strategy. It demanded coordination on an almost unimaginable scale. Factories in the United States ran around the clock, producing not just aircraft, tanks, and munitions, but spare parts, engines, and materials that sustained every frontline unit. Transportation networks ensured that these machines of war reached Europe in weeks, not months. Forward bases and repair depots returned damaged aircraft to service with astonishing speed. Reconnaissance and intelligence units continually informed tactical decisions, guiding every strike with precision. The integration of these components transformed America into what Churchill had termed the arsenal of democracy, a nation capable of sustaining the fight against tyranny through sheer industrial and technological superiority. For the men and women who labored in factories, repair depots, and airfields, the war was a deeply personal mission. Each bomber assembled, each tank repaired, and each runway laid represented not only a contribution to victory, but a safeguard for soldiers in combat. Families traced the deployment of their loved ones' work overseas, finding pride in knowing that the aircraft and machines they had touched with their hands were directly influencing the course of the war. This intimate connection between the home front and the battlefield created a sense of collective purpose unparalleled in modern history, a demonstration that national unity and industrial capability could be wielded as decisively as soldiers on the front lines. In the air, pilots continued their ceaseless campaigns, striking deep into the remaining pockets of resistance. Precision bombing shattered what little remained of German production and transportation. Even in the final weeks, missions were flown to prevent any last-ditch efforts to repair fuel plants, armaments factories, or rail systems. Each sortie further weakened the enemy and accelerated the inevitable surrender. By this stage, the American air campaign had matured into an unbroken chain of dominance, commanding the skies, controlling logistics, and projecting power across vast distances with almost mechanical inevitability. As the Third Reich crumbled, the lessons of the air and industrial campaigns became clear. Victory was not solely achieved through the heroism of combat units, but through foresight, coordination, and the relentless application of industrial might. Knowledge, intelligence, and production had become as lethal as any bomb or shell. The ability to anticipate the enemy's moves, to produce weapons and materials at an unparalleled scale, and to deliver them precisely when and where needed proved decisive. The war had been won not only in the air or on the battlefield, but in factories, offices, and workshops across the Atlantic, demonstrating a form of strategic power that reshaped the future of warfare. The surrender of Germany in May 1945 marked not only the end of hostilities, but the validation of this new approach to war. Cities, towns, and industrial zones bore the scars of air campaigns designed to incapacitate the enemy, while soldiers and civilians alike recognized that their efforts, whether in factories, depots, or intelligence centers, had directly contributed to liberation. The orchestration of production, strategy, and operational excellence created a synergy that ensured the Allies would not merely survive the conflict, but decisively dictate its outcome. In effect, America's industrial and aerial prowess had rewritten the rules of total war. Finally, the legacy of this immense effort extended far beyond Europe's borders. The organizational innovations, technological advances, and operational strategies developed during the campaign became the foundation for post-war military doctrine, industrial policy, and international strategy. The notion that wars could be won through integrated industrial might, intelligence superiority, and sustained air power shaped the Cold War and the modern military era. More importantly, it proved a profound truth. When a democratic society marshals its people, industry, and technology with purpose and discipline, it can confront tyranny and alter the course of history. The sky, the factory, and the home front had together forged the instruments of victory, leaving a permanent mark on the world.